Today I'm going to show you how to run and set up the Island Biogeography Theory lab in your classroom. What you need for this lab is some poster paper, and on this poster paper you're going to make, with a template, a mainland in the middle, and then two big islands and two small islands. So the theory of island biogeography is by E.O. Wilson, and it says that a close island has more to the mainland, has more biodiversity than a far island, and bigger islands have more biodiversity than smaller islands. So we start off with a mainland, and then we have a large close island, a large far island, a small close island, and a small far island. And so in the teacher's guide, I gave you some templates with a little bit of instructions on how to create your posters. I make one per group of 4. So I make these, so you have the templates for these, and then you can trace them onto file folder paper. And then I just had student lab assistants make my posters for me. And in the middle, I wrote that it's a mainland or continent. So the kids kind of understood. I said, yes, I know it looks like an island, but it's really representing the mainland or continent. And I put a big dot in the middle because they need somewhere to aim. So in this lab, they're going to take a funnel. So funnels are pretty cheap to find. I found these for $1 each at IKEA, and any kind of bean. And they're going to pour 100 through the funnel at a time, but they need to pour it slowly. So with these templates, mine is folded up because I had to transport it home. I roll them up in class, and I kind of roll them up loosely and then spread them out starting about a week before I use them, because we don't want any folds or creases in them. It will alter the data. So my students usually, I try and fold them out. You can even use a very, very slightly warm iron, so almost cool iron, if you want to. I don't ever do that. But what I do in my class, I'm looking for my meter stick. I don't see my meter stick, but I take the meter stick. I have them take 2 meter sticks on the lab table and put them on either side to sort of hold the sides down. Okay, and then the directions say to take a ruler, and it's about 1 foot. I think I tell them in centimeters because it is science after all. Above the dot, they're going to pour the beans through. Now, they have to watch. So there's 4 people in a group. The ones not pouring need to make sure that this doesn't sway and it doesn't tilt, because a lot of times kids don't even know, but they're actually tilting it in a certain direction, which will alter the results. So they're going to pour it slowly, and they need to take away the ruler. A lot of times they want to hold this here, but this is going to alter the results because the beans are going to ricochet off of the ruler. So I say, just, you know, hold it here. It's not, if you move it a little, it's not a big deal. And so they're going to pour them slowly through. Now they can't pour it fast because it will jam in the hole. So I tell them to pour it slowly through. Now I have peas here, but I don't recommend peas. They're just what I had on hand here at home, dried peas. I recommend beans because the peas roll too much off of the paper. A bean is flat on one side, and so that will not roll as much. So I recommend small beans. Not the big kidney beans, but very small dried beans. They work better in this lab. So they're going to pour through all 100 of your seeds. Now if they jam, like this one jammed, they just pour it back through like this. They don't have to start all the way over, just the ones that jammed. Okay, and then on the paper, and let me show you my paper, but my data is going to be a little bit off because I have creases in my paper. And it has a shadow from me. Let's see. So on my paper, most is going to stay on the mainland. So these are ones, we can say these are species that attempt to migrate. And at the beginning of the lab, it's a 5E lab. And the students review how would a species migrate If you're a bird, that's easy, you fly. But what about mammals, insects, etc.? How do they migrate? And so that's part of the engage part of this 5E lab. This is the explore part. And so they're going to now count the data of what species landed in each island. And if it landed on the line, you can count that the species made it there and is now struggling to get on shore, so you can count that it made it. And so most of our students, and then they gather them back up after they've taken their data, and you can see that on the data sheet. And you do have a teacher's guide explaining this to you. They just put it all back in the cup and they do it 4 more times. And then they're going to get the averages of what landed here and do some math calculations for percentages. It's easy math. So most students, most groups end up with the close island, the large close island having the most biodiversity in the class. On occasion you get a group just from random drops where it's the large far or it's the close small. And that's okay, we can talk about that. We can talk as a class now. How many groups got D, island D, which is the big close one? And out of 9 groups, it's usually 7 or 8 got D. And then on occasion, you have a group just from random draws, or they could have had an error with this. They tilted it by accident or something like that, or there was a crease in their paper, and that can give them an error. So this is the easy part, but this is actually a really counterintuitive concept for the kids because they can figure this out with islands, but then when they have to transfer it to islands of habitat on a continent, like national parks here and there, it's a very hard jump for them to make. And so I've rewritten this lab and revised and revised and revised over several years. For about 15 years now, I've revised the lab to help walk them through the steps. One of the things that you'll notice in the lab is that I take them to Google Earth together. And we look at our school from Google Earth. And surrounding our school, we have patches of wild areas. And our biome is the chaparral. And there's one right behind our school, this little piece of wild chaparral surrounded by houses. And the kids are like, oh, that's my house. Oh, that's my house. And so this piece of island habitat, is this an island in the middle of urban? Oh, yes, it is. Yes, it is. And then we zoom out and we notice in our city or our town how many little islands of habitat there are using Google Earth. That is a very, very valuable tool for them, and to do it as a whole class, because if you do it on their own, they really don't quite get it. But when you do it together as a class and you point out these islands of habitat. So we have our city's in a valley in Southern California, and we have these little island pockets. It's a hilly community, and so higher hills don't have houses because it costs too much to grade the land, and so we have patches of land. But then surrounding our city is bigger wild areas. So I say, well, what would have more biodiversity in our city? Would it be larger ones, larger wild areas left in the middle of the city? Yes. What about the ones closer to the edges of the city, near bigger wild areas? Oh yeah, that would have more. And so Google Earth is a really good way. Okay, so let's say you're really super urban and your school and your kids' neighborhoods don't have wild areas surrounding it. So relate that to parks. So you have parks in your city. So on Google Earth, take a look at the parks. Which of these parks would have the most biodiversity? They're going to have city urban species in them, from squirrels to rats to possums, maybe some coyotes that live in urban areas. So you're going to have biodiversity. So which parks in your town are going to have more biodiversity? So it's going to be the parks that are bigger and the ones that are closer together. So species can migrate between those two parks. And so you'll see on the teacher's guide how I go through Google Earth. And then students relate this to national parks or state parks, and what state parks or national parks are going to have the most biodiversity. Large ones closer together. So it's going to be your greater Yellowstone ecosystem with Yellowstone and Grand Tetons and glaciers, sort of close, not that close. Alaska is going to have more biodiversity because they have larger parks closer together. And then California, I'm sorry about the camera, my dog just bumped the camera. Anyway, California has some larger parks closer together too. So they're going to discover that. And then the question that says, which parks, if you're at Congress and you want to do a new national park, where would you put it? Kids want to say something like Kansas that doesn't have a national park because, well, it doesn't have one, so we need to preserve those species. But that doesn't fall in this theory. That is a good thing to do. It's not a bad thing, but according to the theory of island biogeography, and you're only concerned about biodiversity, you want to place another big park near other parks. And so that's again another counterintuitive part of this lab that is more difficult for students to grasp. All right, so again, I have teacher notes for you and the students for you in the folder. So this is a great lab. Kids get it, they enjoy it, and it stretches their brains, and that's a good thing. All right.